Hello and welcome, this is Majid, and in today's video we will be solving multiple choice question from paper 1 variant 3 of May-June 2020. If you want to go to a particular question, just follow timestamp given in the video description. Let's start. Question 1. Which particle has equal number of protons and neutrons and an electronic structure of 1s2, 2s2, 2p6, 3s2, 3p6. Now this electronic structure means that we have 18 electrons present. Let's find out the number of protons, neutrons and electrons in each of A, B, C and D. First is argon. We have 18 protons, 18 electrons, and number of neutrons is 39 minus 18, we have 21 number of neutrons. And the question says which particle has equal number of protons and neutrons. So the number of protons and neutrons are not equal, therefore it is not argon. B is calcium plus 2, we have 20 protons, 18 electrons because 2 are lost, and number of neutrons is also 20. So we have equal number of protons and neutrons and number of electrons is 18, and this electronic configuration also comes equal to 18 electrons, so it could be part B. Now let's move to part C. We have oxygen. There are 8 protons, number of electrons is 10 because we have -2 charge, and neutrons is 16 minus 8, 8 neutrons. So we have equal number of protons and neutrons, but the number of electrons is 10. So therefore it does not comes equal to this electronic configuration. So it is not oxygen. D is sulfur. We have 16 protons, 16 electrons, and number of neutrons is 32 minus 16, 16. Now we can see that the electronic configuration is not equal to 18, so therefore it is not sulfur. So the only option that is correct is part B. Question 2. Which molecule contains 6 bonding electrons? Now bonding electrons means the electrons that are bonded between the two atoms. Let's draw the structure. First one is NCl3. Nitrogen is in group 5 of the periodic table, so there are 5 electrons in the outermost shell of nitrogen, and chlorine is from 7th group, so it has 7 electrons in the outermost shell. Nitrogen makes single covalent bond with one of the chlorine atom, so the structure will be like this. Nitrogen, 5 electrons, and chlorine atoms will make single covalent bond with nitrogen. So there are 3 bonds present between nitrogen and chlorine, and the bonding electrons are 1, 2, 3, 4, 5, 6. So we have 6 bonding electrons and 1 lone pair of electron is present, so it could be A. Part B is H2S. Hydrogen has 1 electron in the outermost shell while sulfur has 6 electrons, and the structure of H2S will be like this. Sulfur makes a single covalent bond with one hydrogen and one single covalent bond with another hydrogen. The outermost shell has 6 electrons, so therefore 4 electrons are present in the form of lone pairs. Now the bonding electrons are actually 4, so therefore this is wrong. C is Ce2H4. Carbon has 4 electrons in the outermost shell and hydrogen has 1 electron. So let's draw the structure of C2H4. Carbon makes one covalent bond with another carbon, and makes a single covalent bond with 2 hydrogen atoms. The second carbon also makes single covalent bond with 2 hydrogen atoms. Now the bonding electrons are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore this is also incorrect. Third is SF6. Sulfur is from 6th group in the periodic table while fluorine is from 7th group. The structure of SF6 will be like this. Sulfur makes 6 single covalent bond with fluorine atoms. So there are 6 fluorine atoms around sulfur atom. This is the structure of SF6 and you can see there are 12 bonding electrons present. So D is also incorrect. So the only option is A. Question 3. Solid carbon dioxide is similar to solid iodine in its structure. Which statement about solid CO2 and solid SiO2 is correct? Now we know that the structure of iodine is lattice structure because there are equal spaces between the iodine atoms and there is equal arrangement of iodine atoms present in the solid structure. A. Both solid carbon dioxide and solid SiO2 exist in a lattice structure. In SiO2, one silicon is bonded to 4 oxygen atoms directly, and each oxygen is further bonded to 2 silicon atoms directly. So there is regular arrangement of atoms and there are even spacing, so therefore it is also a lattice structure. So this could be the correct option. Part B. Both solid CO2 and solid SiO2 have a simple molecular structure. Solid SiO2 does not have a simple molecular structure because the structure is continuous and it is called giant molecular structure. C says both solid carbon dioxide and solid SiO2 have atoms joined by single covalent bonds. In SiO2 there are single covalent bonds, but in carbon dioxide carbon is making double covalent bond with oxygen atom. So this is incorrect. D. Both solid carbon dioxide and solid SiO2 change spontaneously to gas at standard temperature and pressure. It is correct for carbon dioxide, but silicon dioxide does not change easily because the bonds are very strong and it needs a lot of heat. So therefore this is incorrect. The only correct option is A. Question 4. The enthalpy changes of two reactions are shown. We can see potassium carbonate reacts with HCl to produce this product. Potassium hydrogen carbonate also reacts with HCl and forms salt, water and carbon dioxide. Enthalpy changes are given. What is the enthalpy change for the reaction shown below? So we have to find the enthalpy change for this given reaction. As we have similar products in both of the reactions, so therefore let's draw a triangle and apply Hess's law. Potassium hydrogen carbonate reacts with HCl to produce potassium chloride, water and carbon dioxide. Potassium carbonate also reacts with 2 moles of HCl to produce same product. In order to balance this equation, we have 2 potassium chloride. The conversion of potassium hydrogen carbonate into KCl, H2 and CO2 could be written as A. The conversion of potassium hydrogen carbonate into potassium carbonate, water and carbon dioxide can be written as B, and this one as C. Now according to Hess's law, this is one step reaction and these are 2 steps. So therefore A is equal to B plus C. We have to find the enthalpy change in reaction B. For reaction A, we have 2 moles of potassium hydrogen carbonate. So therefore the value of enthalpy change must be multiplied by 2. So A is 2 into 32.8. B is to be found. The enthalpy change in C is 1 number of moles of potassium carbonate converts into salt, water and carbon dioxide. So we will write minus 34 kilojoule per mole. Minus 34. So it is 65.6 is equal to B minus 34, or B is equal to 65.6 plus 34, and it comes to be 99.6 kilojoules per mole. So therefore answer is D. Question 5. Nitrogen reacts with oxygen to form nitrogen monoxide and nitrogen dioxide. Nitrogen dioxide reacts with water and with hydroxide ions. These are the chemical reactions given. What can be deduced using only the information from these equations? So we have to find out the answer using these 4 equations. A. HNO2 is a strong acid. Now strong acid is such a substance that dissociates immediately into its ions. H plus ion is formed and an NO2 negative ion is formed. From these chemical equations we can see that HNO2 is not dissociated into its ion, so therefore this option is not correct. B. HNO3 is a weak acid. As we can see that HNO3 has dissociated into its ions. So therefore it is a strong acid, not a weak acid. This is also incorrect. NO2 is a neutral gas. In this equation we can see that NO2 reacts with an alkali to form NO2 negative, NO3 negative and H2O. So therefore it is not neutral, it is acidic gas. D says NO is a reducing agent. We can see in this equation the oxidation state of nitrogen is +2, while in the product the oxidation state of nitrogen is +4. So it is oxidized, and the substance oxidized is called a reducing agent, so therefore this is correct. So the only option is D. Question 6. Which solution has the lowest pH value? Or we can say which is the strongest acid among these. Butanoic acid produces 1 mole of H plus ions. If we have 1 mole of butanoic acid, it produces 1 mole of H positive ions. Similarly, if we have 1 mole of ethanoic acid, it will also produce 1 mole of ethanoate ions. For 1 mole of HCl, we will produce 1 mole of H positive ions. But for 1 mole of sulfuric acid, actually we can produce 2 moles of H positive ions. Now butanoic and ethanoic acid, they are weakly ionized, so therefore they are weak acids. HCl is a strong acid and H2SO4 is also a strong acid, but the number of H positive ions in the similar molarity or similar concentration of these acids is H2SO4 will have more number of H positive ions, so therefore H2SO4 is strongest acid among these two. Also we can say that HCl is monobasic acid and H2SO4 is dibasic as it produces 2 moles of H positive ion. So therefore the acid having lowest pH value will be sulfuric acid. Question 7. The element sulfur produces a mass spectrum with the following peaks. So these are the value of mass to charge ratio of these peaks, and this is the relative abundance of each isotope. Which relative atomic mass of sulfur can be calculated from these data given to 4 significant figures? Now the average atomic mass can be found from this formula. Average relative atomic mass is equal to the mass to charge ratio of first isotope into its relative abundance plus mass to charge ratio of second isotope into its relative abundance plus third one plus fourth value. We have 36 into 0.02 divided by 100. The AR values come to be 3040.64 plus all these divided by 100. AR is equal to 3208.592 divided by 100. So it is 32.0859. Now they have asked answer to 4 significant figures. So therefore taking these 4 significant figures as we have this value as 5, so it will be converted into 32.09. So therefore answer is C. Question 8. What is electronic configuration of an isolated nickel +2 ion? The atomic number of nickel neutral is 28. So we have 28 electrons in the nickel atom. So let's first find out the electronic configuration of neutral nickel. We can write Ni is equal to argon 18, 3d8, 4s2. When nickel is converted into nickel +2, it means 2 electrons are lost, and electrons are lost from 4s first. So therefore the electronic configuration will be argon 18, 3d8, 4s0. In these 4 options we have 18 electrons up till 3p6. So we have 3d8 after 18 electrons, so the only option that is correct is D. Question 9. At 200 degrees centigrade, aluminum chloride is a gas with Mr 267. What is the number of covalent bonds, dative covalent bonds, and lone pairs of electrons in one molecule of aluminum chloride at 200 degrees centigrade? Now, as aluminum chloride exists in the form of a dimer, so the formula is Al2Cl6 and the Mr will be equal to 267. Now we have to draw the structure of this aluminum chloride. In this dimer of aluminum chloride, we have two aluminum atoms. Each aluminum is bonded to three chlorides. The second one is Al, Cl, Cl, Cl. Now we can see there is deficiency of electron around aluminum atom. There are only 6 electrons. In order to overcome the deficiency of electron, aluminum actually makes a dative covalent bond with chlorine atom. Similarly, this aluminum takes 2 electrons from this chlorine atom and a dative covalent bond is formed. Now each chlorine atom has actually 7 electrons in the outermost shell, out of which 6 are present in the form of lone pairs. So we can draw like this. So we have 6 covalent bonds, 1, 2, 3, 4, 5, 6. 2 dative covalent bonds, 1 and 2, and rest are the number of lone pairs. So just counting the number of lone pairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this option seems to be correct. So it is B. Question 10. When solid potassium chlorate is heated in the absence of air, a mixture of 2 chlorine compounds in the mole ratio of 3:1 is formed. Chlorine is the only element whose oxidation number changes. It means the oxidation number of potassium and oxygen does not change. In the reaction, what could be the oxidation number of chlorine in the 2 compounds that are formed? Now let's write the balanced chemical equation for decomposition of potassium chlorate. We have KClO3. It decomposes into 2 different chlorine compounds. So as the mole ratio of products is 3:1, so we can write 3 and 1. So it means the number of moles of the product is 4. So the number of moles of the reactant must also be 4. Now we can balance the number of potassium atoms by writing K. There are 3 potassium on this side and 1 potassium on this side, so the 4 potassium atoms are balanced. For chlorine, we have 3 on one side and 1 on one side, so we can write Cl and Cl. For balancing oxygen, we have 12 number of oxygen atoms and 12 is a even number. So therefore we cannot add 1 as it will become odd, so therefore we can write 4 number of oxygen atoms, 3 4s are 12. And there is no oxygen atom on this product. Now this equation seems to be balanced. Now let's find out the oxidation state of chlorine atom in both these compounds. In potassium chloride, we have +1 for potassium atom and -1 for chlorine, so therefore chlorine oxidation state is -1. In KClO4, we can write KClO4. There is 1 potassium atom, 1 chlorine atom, 4 oxygen atom, and the overall charge is 0. So we have chlorine -7 is equal to 0, chlorine is equal to +7. So therefore oxidation state of chlorine is +7. So it is +7 and -1. So therefore answer is C. Question 11. 2 reactions are shown. This is the first reaction. This is the second reaction. The equilibrium constant Kp for reaction 1 is 0.0052. What is Kp for reaction 2? Now in order to find the Kp for reaction 2, we need to find if there is any relation between Kp of reaction 1 and Kp of reaction 2. So for first reaction we have Kp1. It is equal to the pressure of xy raised to the power the number of moles divided by pressure of x2 into pressure of y2. We can write it in the form of brackets. For Kp2 we can write Kp2 is equal to the second equation. We have pressure of x2 raised to the power its number of moles multiplied by pressure of y2 raised to the power its number of moles divided by pressure of xy, and the power is 1. We can write the value of for Kp1 we have 0.0052 and it is equal to the pressure of xy square divided by pressure of x2 into pressure of y2. So reverting this equation we can write 1 over 0.0052 will be equal to the pressure of x2 into pressure of y2 divided by pressure of xy raised to the power 2. Now taking under root on both sides we have the value comes to be 13.86, and on this side we can write pressure of x2 raised to the power 1 by 2 into pressure of y2 raised to the power 1 by 2 and pressure of xy 2 into 1 by 2. Now we can see that this side and this side are actually the same, so we can write Kp2 in place of this equation part. So 13.86 will be equal to Kp2, or we can also round it off to 13.9. So therefore answer is B. Question 12. Compound T is a white crystalline solid. When a sample of compound T is mixed with aqueous sodium hydroxide and heated, a gas is produced which turns damp red litmus paper blue. Further testing of solution of compound T with aqueous barium chloride produces a dense white precipitate which does not dissolve when dilute hydrochloric acid is added to the mixture. What is the identity of compound T? Now we know that whenever we have ammonium salt present and it is heated in the presence of aqueous sodium hydroxide, so ammonia gas is released. And ammonia gas turns damp red litmus paper to blue. So it means compound T could be a salt of ammonium ion. So it could be ammonium carbonate or ammonium sulfate. It is not sodium carbonate or sodium sulfate. Now let's find out the reaction of ammonium carbonate and ammonium sulfate with barium chloride. We have ammonium carbonate plus barium chloride. It will form barium carbonate solid and ammonium chloride salt. Let's write the second chemical equation of ammonium sulfate with barium chloride. It forms barium sulfate and again ammonium chloride. Now both barium carbonate and barium sulfate are white in color and both produce white precipitate. The question says white precipitate which does not dissolve when HCl is added. So let's find out which of these does not react with HCl. So barium carbonate reacts with HCl to form barium chloride plus water plus carbon dioxide, while barium sulfate, it does not react with HCl. So therefore the salt that is asked in the question is barium sulfate. Therefore answer is B. Question 13. Which property explains the trend in volatility of the elements going in group 17? We know that in group 17 volatility basically depends on the intermolecular forces of attraction. And higher the intermolecular forces of attraction, less will be the volatility of elements. In group 17, first we can see there is gas, fluorine is gas, chlorine, bromine is low boiling liquid. Then we have iodine, which is a solid. So the volatility of the elements going down in group decreases. Let's see which options are correct. A. Decreasing covalent bond strength. Now the covalent bond has nothing to do with the volatility of the elements, only intermolecular forces are involved. Decreasing van der Waals forces. Down the group, van der Waals forces actually increase, so this is also wrong. Increasing covalent bond strength, this is nothing to do. And D is increasing van der Waals forces, this is the correct option. So the answer is D. Question 14. The statements apply to the elements in group 2. Which statement is correct? A. As atomic number increases, ionic radius increases. Yes, we know that in going down in the group 2, what happens that in each period another shell is added, so therefore ionic radius increases. This is correct. As atomic number increases, reducing ability decreases. No, this is wrong, because reducing ability increases because elements can easily lose electrons down in group 2. As atomic number increases, first ionization energy increases. Now as the atomic size increases, the first ionization energy actually decreases because the attraction between the outermost electron and the nucleus becomes less. D says as atomic radius increases, first ionization energy increases. So this is also wrong. So the only correct option is A. Question 15. Which element when burned in oxygen can form an oxide that is a reducing agent? Sodium will form sodium oxide, magnesium will form magnesium oxide, aluminum will form aluminum oxide, and sulfur will form sulfur dioxide. In these compounds we can find the oxidation state. Sodium is in +1, magnesium is in +2 oxidation state, aluminum is in +3, and sulfur is in +4. You should remember this statement that any normal oxide in which the metal or the other non-metal is in its highest possible oxidation state cannot be further oxidized. The oxidation state of sodium in sodium oxide is maximum, so therefore it cannot be further oxidized. So it is not sodium oxide. Similarly, magnesium oxide, the maximum oxidation state is +2 and it is already achieved, so it cannot be further oxidized. Similarly, aluminum cannot be further oxidized. Now sulfur dioxide has the ability to actually reduce nitrogen dioxide into NO and itself get oxidized to sulfur trioxide. In SO3, sulfur has +6 oxidation state. So the only possible option which can further oxidize itself or behave as a reducing agent is sulfur. So the answer is D. Question 16. Nitrogen oxides are removed from the exhaust gases of internal combustion engines by the action of catalyst in a catalytic converter. Which row is correct? Now in catalytic converter, this reaction takes place. Carbon monoxide reacts with nitrogen monoxide to form carbon dioxide and nitrogen gas. In catalytic converter, the catalyst that is used is solid platinum, and there is a lot of heat present in the engine. Now let's find out the oxidation states of nitrogen. Nitrogen is +2 on the reactant side and 0 on the product side. So nitrogen has actually reduced. Also, carbon monoxide is in gaseous form, nitrogen monoxide is gas, carbon dioxide is gas, nitrogen is gas. But the catalyst is in solid form. Let's find out the answers. First one is change in oxidation number of nitrogen. It decreases or increases. As we can see, it goes from +2 to 0, so it decreases, so therefore it could be A or B. Type of catalyst. Now catalyst is in solid form while the reactants and products are in gaseous form, so therefore it is not homogeneous, it is heterogeneous catalyst. So the correct option is A. Question 17. The addition of aqueous silver nitrate to aqueous barium chloride produces a white precipitate which dissolves in an excess of dilute aqueous ammonia to form a colorless solution. The addition of an excess of dilute nitric acid to the colorless solution produces a white precipitate Z. What is Z? Now let's write the first chemical equation. We have silver nitrate and it reacts with barium chloride. So AgNO3 plus barium chloride solution. It forms silver chloride precipitate and barium nitrate solution. Now silver chloride is in the form of white precipitate and it actually dissolves in aqueous ammonia, NH3 aqueous, to form a complex AgNH3 to Cl. Second part of the question says the addition of excess dilute nitric acid to the colorless solution. It means let's just add HNO3 to this compound. We have ammonium nitrate and silver chloride. Now silver chloride is in the form of precipitate while ammonium nitrate is the soluble salt. So therefore option is A, silver chloride. Question 18. Which property shows an increase from calcium to barium going down in group 2? A. The ease of decomposition of the carbonates. Now the carbonates of group 2 actually become more stable going down in group 2. This is because whenever we go down in group 2, the size of cation increase. And when the size of cation increase, it means the polarizability of the cation actually decreases down the group. When the polarizability decreases, so therefore bond strength increases and therefore it is difficult to decompose the carbonate. So while comparing calcium carbonate with barium carbonate, the size of barium plus 2 ion is far larger as compared to the size of calcium plus 2 ion. So therefore barium carbonate is much more stable than calcium carbonate. So the ease of composition does not increase, it decreases. So therefore A is incorrect. B says the solubility of hydroxides. Now as we move down in group 2, the solubility of hydroxide actually increases and we can see that barium hydroxide is far more alkaline as compared to calcium hydroxide. This is because barium hydroxide easily produces hydroxide ions. So this could be correct. C says the solubility of the sulfates. The solubility of sulfates decrease going down in group 2. And we can see that barium sulfate is far more insoluble as compared to calcium sulfate. D. The volume of hydrogen given off when 1 gram of the metal reacts with water. Now if we take 1 gram of the metal and going down in group 2, the atomic number actually increases. The atomic mass also increases. So the number of moles become less and less as we move down in group 2. Because moles is equal to mass in grams divided by atomic mass. So therefore as the number of moles will decrease, the volume of hydrogen given off will also decrease. So therefore this is also incorrect. Correct option is B. Question 19. Element X is in period 3. It reacts rapidly with water to form an alkaline solution. Which statement about the chloride of element X is correct? Now in period 3, elements like sodium, magnesium, aluminum, silicon are present and it says it reacts rapidly with water to form an alkaline solution. Now sodium reacts with water to form sodium hydroxide, magnesium forms magnesium hydroxide, aluminum metal does not react with water, similarly silicon also does not react with water. So it could be sodium or magnesium. Now comparing the reaction of sodium and magnesium with water, we can see that sodium reacts rapidly with water while magnesium reacts slowly. The second part of the question says which statement about the chloride of element X is correct. So it could be the chloride of sodium as NaCl. Let's find out. A. It conducts electricity when molten. So yes, sodium chloride when in molten form it forms ions. So therefore it is a good conductor. B. It has a melting point of less than 100. Now we know that the melting point of sodium chloride is above 700. So this is incorrect. C. It has covalent bonding. No, the bonding is ionic. D. It reacts rapidly with cold water. It does not react, actually it dissociates into ions. So the correct option is A. Question 20. Structural and stereoisomerism should be considered when answering this question. When trans-pentoene reacts with HBr, how many different products can form? Now stereoisomerism means cis-trans or optical isomerism. For cis-trans, presence of double bond is must. For optical isomerism, presence of chiral carbon is must. Now trans-pentoene reacts with HBr. Let's draw the structure formula of trans-pentoene. We have 1, 2, 3, 4, 5 carbon atom, and we have hydrogen atoms. This is trans-pentoene because you can see that the similar hydrogen atoms are actually on the opposite side. If both hydrogen were on the similar side, then it would be cis-pentoene. Now it reacts with HBr. Let's draw the possible products that are formed. CH3, CH2. Now HBr is added around the double bond. With one carbon atom we can add hydrogen, and with second carbon atom we can add bromine. Now the second product could be like this. Again we have carbon and hydrogen, CH3 and hydrogen. Now in this product, bromine atom is attached to this carbon atom while hydrogen atom is attached to this one. Let's find the names of both of these compounds. The first one is 1, 2, 3, 4, 5. We have bromine on second carbon, so it will be 2-bromo-pentane. In second compound we can see 1, 2, 3. Bromine atom is attached to the third carbon atom, so it should be 3-bromo-pentane. So both these are examples of structural isomerism. Now we have to find the stereoisomerism. There is no cis-trans possible because there is no double bond. Now let's find out the optical isomerism. Now for optical isomerism there must be a chiral carbon present. Let's find out the chiral carbon. This is not chiral, this is not chiral, no. This carbon atom is chiral because it is attached to one CH3, one Br, one hydrogen and one this group. So it means optical isomerism is possible for this product. Let's find out chiral carbon in second group. We have this carbon. For this carbon you can see that we have C2H5 attached on this side and C2H5 on this side, so therefore this is also not chiral. So we have three products. One is 2-bromopentane, second is 3-bromopentane, and third one is the optical isomer of 2-bromopentane. So the answer is C. Question 21. Ester P has the following structural formula. This is ester. Which compounds are produced when P is hydrolyzed using dilute HCl? Now we should know that whenever ester is hydrolyzed in the presence of acid, so then ester is broken into carboxylic acid and alcohol. The bond from this oxygen and this R groups breaks, and H plus is attached to this oxygen while OH is attached to this carbon atom. So we have carboxylic acid and alcohol formed. So the products will be CH3, C double bond O, OH, and second product will be CH3, 2, CH, CH2, CH2, OH. The answer that is similar to these two products will be D. Question 22. There are many non-cyclic alcohols that cannot be oxidized by warm acidified manganate ions. Alcohol X is the member of this set of alcohols with the lowest molecular mass. Now we know that there are three types of alcohols. One is primary alcohol, second is secondary alcohol, third is tertiary alcohol. Primary alcohol and secondary alcohol both can be oxidized by manganate ions. Only tertiary alcohol cannot be oxidized. Let's find out the tertiary alcohol having lowest molecular mass. So tertiary alcohol is such an alcohol in which hydroxide is attached to the carbon atom, and this carbon is directly attached to three other carbon atoms. We will have three alkyl groups. This is the structure of tertiary alcohol having lowest molecular mass. Let's find the molecular formula. The molecular formula is C4H10O. Now second part of question says, how many moles of oxygen are required for complete combustion of 1 mole of alcohol X? Let's write the balanced equation for the combustion of this tertiary alcohol. We have C4H10O. It combines with oxygen to form CO2 and H2O. Balancing number of carbon atoms, we have 4 carbon on the reactant side, so it will be 4. Hydrogen atoms, there are 10 hydrogen atoms, so we can write 5 with H2O. We have 8 and 5, 13 oxygen atoms on the product side, so we can write 6 with oxygen, so it will become 12, and 1 is this one, so 13 oxygen are balanced. Now according to this balanced equation, we have 1 mole of this tertiary alcohol and 6 moles of oxygen are required. So therefore answer is C, 6 moles. Question 23. Butanoic acid can be produced from 1-bromopropane in 2 steps using reagents V and W. So 1-bromopropane converts into compound Q and then converts into butanoic acid. What could be the reagents V and W? Now in 1-bromopropane we have 3 number of carbon atoms, while in butanoic acid we have 4 carbon atoms. So in order to increase the number of carbon atoms we can use cyanide, so it could be KCN or this one. Let's write the chemical reaction. We have bromopropane when it reacts with KCN, cyanide ion actually replaces bromide, so it becomes nitrile plus KBr. This is butane nitrile. Now butane nitrile can be converted into carboxylic acid by using aqueous HCl. So it will form carboxylic acid CH3, CH2, CH2, COOH along with the salt of ammonium. So we have used potassium cyanide and HCl, so therefore answer is A. Question 24. Which statement about compound T and compound U is correct? This is compound T and this is compound U. Now we can see both have carbonyl carbon. In compound T, on both sides of carbonyl carbon, alkyl group is present, so therefore it is ketone. In compound U, there is alkyl group on one side and a hydrogen atom on the other side, so therefore this is aldehyde. A. T and U are stereoisomers. Now stereoisomers can be of 2 types, one is cis trans, another is optical isomer. For cis trans, alkene is must, so therefore neither of the compound T and U are alkenes, so therefore cis trans is not possible. For optical isomers, there must be a chiral carbon, so there is no chiral carbon present in compound T, so therefore it does not show stereoisomerism. B. T can be distinguished from U by the use of alkaline aqueous iodine. This is the iodoform test, and we know that for positive iodoform test there must be methyl group directly attached to the carbonyl carbon. So as this group is present in compound T, so therefore compound T will give positive result with aqueous iodine. So B seems to be correct. C. T can be reduced by lithium aluminum hydride but not by sodium borohydride. Now T is a ketone and ketone can be reduced by both lithium aluminum hydride and NaBH4. Both will convert compound T into secondary alcohol, so therefore it is not correct. D says U can be formed by the oxidation of 3-methyl-butane-1-ol. Let's draw the structure of 3-methyl-butane-1-ol. We have 4 carbon atoms in the long chain. On third carbon atom we have methyl group attached, and on first carbon we have OH group attached. Now this is an example of primary alcohol because OH group is attached to the carbon atom which is directly attached to one carbon atom. So therefore primary alcohol can be oxidized to aldehyde and the product formed will be CH3, CH, CH3, CH2, C double bond O, H. Now the structure of compound U is like this. We have CH3, CH2, CH. CH3 is directly attached to CH because it is in bracket. Then we have carbonyl carbon and hydrogen atom. Now the name of this compound is 2-methyl-butanol, while the name of compound formed by oxidation is 3-methyl-butanol. So therefore they are not the same, so therefore this is wrong. So the only option that is correct is B. Question 25. The diagram shows the infrared spectrum of an organic compound. This is the infrared spectrum. Now we can see the peaks. This one is important. And second is this peak. This region is important. Now this region is from 1680 to 1730, while this region is from 2500 to 3100 per centimeter. Now we know that according to data booklet, carbonyl carbon gives the peak between 1680 to 1730, and carbonyl carbon is present in aldehydes, ketones, carboxylic acids, and esters. The second peak is from 2500 to 3100, and according to data booklet this will be shown by the carboxylic acid OH bond. So this bond actually shows this peak. The options are propane 1-ol, so there is no peak of alcohol group. We have propanol, so aldehyde does give a peak from 1680 to 1730. Propanoic acid, this gives both peaks, both from 2500 to 3100 and 1680 to 1730, and propanone also gives only one peak of carbonyl carbon. So therefore this compound should be propanoic acid. Question 26. Which reagent reacts with both of the OH groups in lactic acid? Let's draw the structure of lactic acid. We have CH3, CH, OH, and C double bond O, OH. Now this is secondary alcohol group and this is carboxylic acid functional group. A. Acidified potassium dichromate. It can oxidize secondary alcohol group to ketone. B says ethanol. Ethanol can react with the carboxylic acid functional group to form ester. So it reacts with COOH to form ester. C is sodium. Sodium reacts with alcohol group and also reacts with carboxylic acid group. Sodium will react with this lactic acid and will form sodium alkoxide with OH group. And sodium salt with carboxylic acid along with the hydrogen gas. D is sodium hydroxide. So sodium hydroxide is an alkali, so it will react only with the carboxylic acid group to form salt and water. It won't react with OH group. So the only option that can react with both OH group and carboxylic acid group is sodium. So answer is C. Question 27. 1,2-dibromopropane can be made from 1-bromopropane in 2 steps. Which row is correct? This is 1-bromopropane, CH2, CH2, CH3. We have bromine atom on first carbon atom. Now first this compound can be reacted with sodium hydroxide ethanolic. Elimination will occur and HBr is removed from this compound, so we will have CH2 double bond CH CH3 plus NaBr plus H2O. Now in order to make this alkene into 1,2-dibromopropane, we can add aqueous bromine. So the product would be CH2 Br CH Br CH3. Now the first step was elimination and second step is addition. So therefore answer is B. Question 28. 2-methyl-butene reacts with HBr gas to form two isomeric products. During the reaction, two positively charged intermediates can be made. Which diagram shows the more stable of the two positively charged intermediates? Let's first find out which type of intermediate is formed during the reaction. So we have 2-methyl-butene. On second carbon we have double bond. It reacts with HBr as Br is partial negative and hydrogen is partial positive. So therefore H plus will be attached to the carbon atom with the double bond. With one of the carbon atom H plus is attached and on the second carbon atom cation will be formed. Now for the product there are two possibilities. One is that hydrogen combines with the first carbon atom and second carbon becomes the positive ion. Second possibility is that the hydrogen attaches itself to the second carbon atom and cation is formed on the first one. Now in the second step, bromide ion will react with the partial positive carbon atom and will form the product. Now looking at the given options, we can see that C and D are wrong because they have attached bromine first and only A and B are left behind. So among A and B we can see that there are three alkyl group attached with this carbocation and there are two alkyl groups attached to this carbocation. A is tertiary carbocation and B is secondary carbocation. Now tertiary carbocation is always more stable than secondary carbocation because of the presence of alkyl groups. And due to the alkyl groups, there is electron donating effect and it stabilizes the intermediate carbocation. So therefore A is more stable among A and B. Question 29. The ester ethyl methanoate is prepared in the laboratory by reacting a carboxylic acid with an alcohol. During the reaction, only 50% of the alcohol is converted into the ester. Which mass of alcohol is needed to prepare 10 grams of the ester? As the name of the product says ethyl methanoate, so it means it is made from ethanol and methanoic acid. Let's draw the structures. Ethanol is CH3, CH2, OH. Methanoic acid is HCOOH. And the product form will be like this: HC double bond O, O, CH2, CH3. This is ethyl methanoate along with water molecule. Let's write molecular formula of all these three. We have 2 carbon atoms, 6 hydrogen atoms, 1 oxygen. We have 1 carbon, 2 hydrogen, 2 oxygen, and we have 3 carbons, 6 hydrogens, 2 oxygen along with H2O. Now this equation is already balanced. We have 1 moles of alcohol which produces 1 mole of ester. Let's find how many moles of ester are there in 10 grams. So mole is equal to mass in grams, which is 10 gram divided by mR. The mR of ester is 36 for carbon atoms, 6 for 6 hydrogen atoms, 32 for 2 oxygen atoms, and we have 0.135 moles. Now according to the ratio, if 1 mole of alcohol makes 1 mole of ester, so 0.135 moles of ester are produced from 0.135 moles of alcohol. In the question they have asked about the mass of alcohol, so using the formula of mass, it is equal to moles into molecular mass. So moles is 0.135 and mR of alcohol is 24 for carbon, 6 for hydrogen, and we have one oxygen atom. So therefore answer is 12.37 grams. So the answer is C. Question 30. Compound X has the structure shown. Which type of carbonyl group is present and how many chiral centers are there in one molecule of X? As this is the carbonyl group, and on both sides of carbon we can see that two different groups are attached. One is alkyl group and one is this group. So therefore it is ketone. So it could be either C or D. Now let's find the chiral centers. For chiral centers we must have carbon that is attached to 4 different groups directly. So starting from this ring we can see this carbon is making double bond, so it is not chiral. This one is also not chiral. This carbon has 2 hydrogen atoms, so it is not chiral. This has 2 hydrogen atoms, not chiral. This one has 2 hydrogen atoms, not chiral. This carbon has 3 different groups and 1 hydrogen atom, so therefore this carbon is chiral. So we have one chiral center. This carbon has double bond with oxygen, so it is not chiral. This carbon has 3 hydrogen atoms, so it is also not chiral. So there is only one chiral center present. So the answer should be D. Question 31. Which contain 1 mole of the underlying substance under room conditions? 1. A balloon containing 24 decimeter cube of helium. For gases we can find number of moles as moles is equal to volume in decimeter cube divided by 24 decimeter cube. So therefore it comes equal to 1 mole, so this is correct. 2. A block of calcium carbonate weighing 100.1 grams. Now we can find the moles of this calcium carbonate by the formula. Moles is equal to mass in grams. We have 100.1 divided by mR. mR of calcium carbonate is 40.1 plus 12 plus there are 3 oxygen atoms. So therefore answer is 1. So this is also correct. Third is 4000 centimeter cube of a 0.250 mole per decimeter cube solution of sulfuric acid. Now for concentration we can use the formula moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. Putting values given in the question, we have 0.250 concentration into 4000 divided by 1000 as we have converted centimeter cube to decimeter cube. So the answer is 1. So therefore option 3 is also correct. So the answer is A. Question 32. Buckminsterfullerene is a fullerene allotrope of carbon. Which statement about Buckminsterfullerene are correct? 1. Buckminsterfullerene is a giant covalent molecule. As we know that there are only 60 carbon atoms present in one molecule of Buckminsterfullerene, so therefore it is not giant, it is simple molecular. 2. Buckminsterfullerene has delocalized electrons. As we know that in Buckminsterfullerene carbon makes 3 sigma bonds and one of the electron is involved in the pi bonding, so therefore due to the pi electrons there is delocalized system, so therefore 2 is correct. 3 says Buckminsterfullerene has strong intramolecular bonds. Intramolecular means inside the molecule. Now we know that in the Buckminsterfullerene molecule there are 60 carbon atoms and all of them are covalently bonded with each other, so therefore the bonds are strong. So this is also correct. So the option is C. Question 33. Gaseous sodium ions can be formed from sodium atoms. Which quantities are required to calculate the enthalpy change of formation of sodium ion? Now we know that we can find the enthalpy of formation by using Hess's law. We have sodium solid, it converts into sodium ion. Now sodium solid can be first converted into gaseous sodium atom, and then we have first ionization energy, and we can convert sodium atom to sodium ion. So in this step from solid to gaseous, we have enthalpy of atomization involved, while in this step from sodium gaseous to sodium ion, we have first ionization energy involved. So by using Hess's law, we can actually find this enthalpy change of formation. So the options are 1. First ionization energy of sodium. Yes, we need this one. Second is enthalpy change of atomization of sodium. We also need this one. Third is the enthalpy change of formation of sodium. Now this is not needed. So the correct answer is B. Question 34. The Haber process is used in industry to form ammonia from hydrogen and nitrogen. Which statements about the activation energy for this process are correct? 1. The activation energy for the forward reaction is the same as the activation energy for the reverse reaction. As we know that this reaction is exothermic and the enthalpy change is negative, so it means forward reaction is exothermic and backward reaction is endothermic. So therefore the activation energy for the forward and backward reaction could not be the same. So this is incorrect. 2. The activation energy for the reverse reaction is decreased by the addition of iron. As we know that in ammonia we use iron as a catalyst, so iron actually reduces the activation energy, so the reaction goes in forward direction and both the backward direction first. Activation energy is actually decreased in both forward and reverse direction, so it is correct. 3. The activation energy is the minimum energy that colliding particles must possess in order to react. This is the true statement, so therefore it is correct. So option 2 and 3 are correct, so the answer is C. Question 35. Strontium nitrate is heated strongly for several minutes. Which statements are correct? Let's write the chemical equation for the decomposition of strontium nitrate. We have SrNO32 converts into strontium oxide, nitrogen dioxide, and oxygen gas. Part 1 says a brown gas is produced. Now NO2 is the brown gas. So this option is correct. 2. A gas is produced that relights a glowing splint. Yes, we have oxygen gas which is produced, so part 2 is also correct. 3 says a white powder remains after heating. So strontium oxide is actually white in color. So therefore all 3 options are correct. So the answer is A. Question 36. When added to water, which oxide will not cause a change in pH? 1 is aluminium oxide. Aluminium oxide does not dissolve in water, so it won't change the pH. So this could be correct. Silicon dioxide is also insoluble in water and it won't change the pH, while phosphorus oxide is acidic oxide and it will decrease the pH of water. So the correct options are 1 and 2 and the answer is B. Question 37. Propanol reacts with hydrogen cyanide to form 2-hydroxybutane nitrile. A suitable catalyst for this reaction is sodium cyanide. This is the reaction shown. Which statement about this catalyzed reaction of propanol with hydrogen cyanide are correct? 1. The sodium cyanide provides a stronger nucleophile than HCN. Now sodium cyanide can easily dissociate into sodium ions and cyanide ion. And HCN is not dissociated easily, so therefore option 1 is correct. Option 2. The reaction can be classified as nucleophilic substitution. Now we can see in this reaction that cyanide ion carbon has a lone pair of electron, and this carbon is partial positive and oxygen is partial negative. So this carbon will attack to the partial positive carbon of propanol. So cyanide is behaving as a nucleophile, so therefore this is nucleophilic addition. As we can see in the product that cyanide ion is being added. So this is not substitution, this is addition, so therefore this is incorrect. Third option says the hydrogen cyanide molecule attacks the propanol molecule to form an intermediate ion. Actually, hydrogen cyanide does not attack, only cyanide attacks in the form of a nucleophile, so this is incorrect. So we have only one option and therefore answer is D. Question 38, a reaction mechanism is shown. This is the reaction. Which statement about this reaction are correct? Number 1, it is a substitution reaction. Now we can see in the reaction that OH replaces Cl and Cl has been kicked out. So therefore option 1 is correct. Option 2, OH negative behaves as a nucleophile. As OH negative has a lone pair of electron and it is attacking to the partial positive carbon atom, so therefore it is behaving as a nucleophile. This is correct. Third is heterolytic bond fission is involved. As we can see between carbon and chlorine, chlorine becomes negative, carbon is positive. So chlorine atom takes both electrons involved in the bond between carbon and chlorine. So therefore chlorine becomes negative, so it is heterolytic bond fission. All three options are correct, therefore it is A. Question 39. On complete combustion, a sample of X produces 44 grams of carbon dioxide and 27 grams of water. On complete combustion, a sample of Y produces same carbon dioxide and 18 grams of water. On complete combustion, a sample of Z produces 22 grams carbon dioxide and 9 grams of water. Which substance could be a straight chain alkane? Now we have to find the straight chain alkane. Let's first convert these values into moles. So we have 1 mole of carbon dioxide in 44 grams, 1.5 moles of water, 1 mole of carbon dioxide, 1 mole of water, 0.5 moles of carbon dioxide, 0.5 moles of water. Let's write the chemical equation. For first reaction we have 1 mole of carbon dioxide and 1.5 moles of H2O. Now there is complete combustion, so therefore number of moles of oxygen are not required. So there is 1 carbon atom and 1.5 hydrogen, so 1.5 into 2 will be 3. So it means we have 1 carbon atom and 3 hydrogen atoms. Now the general formula for this compound will be CnH2n plus 1. So this is alkane. For second reaction we can write 1 mole of carbon dioxide being formed and 1 mole of water. So we have 1 carbon atom and 2 hydrogen atoms. So it is CH2 plus oxygen. For CH2, the general formula should be CnH2n. So this is the general formula for alkenes. So therefore this is not alkane, this is alkene. For third reaction, we have 0.5 moles of carbon dioxide and 0.5 moles of H2O. Again, the ratio between both carbon dioxide and water is same. Both have 0.5 moles. So we can write CH2 and the moles will be 0.5. Now the general formula for this compound is also CnH2n, so this is also an alkene. So X is an alkane, Y is an alkene and Z is also alkene. So the only correct option is 1 and therefore answer is D. Question 40. Which pairs are structural isomers of each other? Now by structural isomer we mean that having the same molecular formula but different structures. Let's first find the molecular formula. In 1 we have 6 carbon atoms, 12 hydrogen atoms and 2 oxygen atoms. For this compound the molecular formula is 6 carbon atoms, 12 hydrogen atoms and 2 oxygen atoms. Now the molecular formula of both is same, and we can see in the first one we have carboxylic acid functional group, while in the second one we have ester functional group. So therefore they are structural isomers. For second option we can find the molecular formula. There are 6 carbon atoms, so C6. For hydrogen there are 3 hydrogens in the corners and 1 hydrogen with these carbons, so 14 hydrogens are there. For the second option we have 6 carbon atoms, and 14 hydrogen atoms. The molecular formula is same. Let's name both of these. First one is so the name should be this, and this are the methyl groups, so 2, 3 dimethyl butane. For this structure we can say 3 methyl pentane. So the molecular formula for both is same while the structure is different, so therefore they are also structural isomers. For third option we can see the molecular formula first. So we have 6 carbon atoms, 14 hydrogen atoms, 1 oxygen atom for this compound. For this compound we have 6 carbon atoms, 14 hydrogen atoms, 1 oxygen atom. Now let's name this one. In the first one we have OH group attached with this carbon atom, so this is an alcohol, while in second we have OH group attached to this carbon atom, so it is also an alcohol. So the name of this alcohol will be 1, 2, 3, 4, 5, 6. So we have hexane, and OH is attached to the third carbon atom, so hexane 3-ol. For this structure we can see 1, 2, 3, 4, 5, 6. Again it is hexane, and OH is attached to the third carbon atom, so it is hexane 3-ol. So both of these are actually the same compounds, they are not different, so therefore they are not the isomers. So the only correct options are 1 and 2, so therefore answer is B. Thank you for watching. I hope this video was useful. If it is, then please drop a like and subscribe to this channel for more upcoming videos. See you in the next one. Till then, stay happy and keep smiling.